All right. So welcome to OCP Tech Week. I am Philip Corney. I'm the Chief Technical Officer for Penguin Computing, and I want to talk a little bit about how Penguin Computing has been leveraging OpenRack and how we see the power available in an open actual power, electrical power, not just sort of virtual computing power is available. A little bit about Penguin Computing. We're about 20 years old. We were started just before in 1998, so we're a little bit over 20. We are also the home of the Skill Beowulf cluster software that was started by Don Becker, who had sort of invented that style of commodity clustering. And we also run an HPC in the cloud sort of service where you can bring your apps and your data and get your results. So we're not just building HPC systems, but we actually run them. We won a contract with the US Department of Energy to deliver their CTS-1 contract, which delivered over 300 racks of OpenRack v2.1 compatible systems based on OpenRack 2.1 with our Tundra extreme scale nodes. And Tundra is just a Penguin trademark, but basically it's open compute compatible and inspired compute nodes, but optimized for HPC. Me personally, I was honored to be asked by Archana many years ago to be the representative on the HPC community to OCP. That term has passed, but that was a great experience. And anytime you need me again, Archana, I'll be happy to step up again. So to talk a little bit about the Open Compute OpenRack v2.1 spec, it actually has a bunch of different aspects to it. It was with the 2.1 spec. Google merged in sort of two new technologies. One was a short depth, 660 millimeter deep sort of rack design, as well as a 48-volt bus bar design. And so those as options were merged into the 2.1 spec, but in a way that was compatible. It used many of the same mechanical interfaces. It just changed the one dimension, which was the depth, but it kept the same width, it kept the same bus bar locations, but it defined a new bus bar sort of profile so that you couldn't accidentally plug a 12-volt system into a 48 or vice versa. And 48-volt bus bars were designed to be to address some of the concerns about safety and touch and other with the 12-volt bus bars. So you see here the logos for Facebook. Facebook started out with 3 bus bars, which is the left half of this sort of picture. Penguin Computing initially adopted that for our designs, and then Facebook, when they went to 2.0, I guess, didn't see the need for all 3 bus bars any longer, and so eliminated 2 of them and went with a single bus bar solution. But for Penguin, what we wanted to do was deliver a lot more than 10 kilowatts in a rack. As Nicholas was talking about, Dennard scaling has stopped. CPU power levels are getting higher and higher, and I'll talk about that in a minute. And so we're seeing that node power levels, and also we wanted to get node density. In the HPC community, it was common to have upwards almost as many as 80 nodes in a rack, and a rack the size of a standard EIA 19-inch. HPC also have racks that are much larger than a standard EIA rack with custom form factors. But in a standard form factor, large numbers of nodes was normal. Power levels, many years ago, 10, 20 kilowatts in a rack, which were easily twice what Facebook was targeting, were possible and reasonable. So, but the gold star there, where we take advantage of 48 volts, we use 3 bus bars, and the deep chassis design. we think is really kind of the sweet spot, and something we like to highlight and point out that this is a viable profile out of the Open Rack specification. So I was talking about power levels, right? And why do we need a high power rack spec? I went back and looked at power levels for different sort of processors, different times, and what kind of power cords that we were using, right? So back just 10 years ago, a 300-watt node was kind of typical in my experience, which leads to 30 nodes in 300 watts, gave you about 10 kilowatts per rack, which was reasonable 10 years ago. You could feed that with a couple of 20 amp 3-phase plugs, and you'd be all set. But nowadays, into 2020, we're looking at 250 watt procs, 700 watts, 800 watts power dissipation per node. And if you put 80 or 90 nodes in a rack, as we can do with a 1U 3-wide form factor, that's 60, 70 kilowatts per rack and growing. And so using that this profile that we were talking about, 48 volts, 3 bus bars, deep rack design, we've designed an Open Compute 2.1 compatible rack that could do 100 kilowatts in one rack with standard OCP compliant equipment. And we think that's an important capability. And in fact, we're actually sort of limited by the power cords to the rack, right? A 60 amp 277 high voltage feed is only good for about 30 to 40 kilowatts. So that as a practical limit, 80 kilowatts is kind of the practical limit in a rack. But you end up with more than 2 cords, which becomes somewhat of a challenge for the data center sometimes. And overhead bus bars and other things, data center issues become challenges. So that was most of what I had. I understand we're behind schedule, so I think I'll yield the balance of my time, maybe get us back on schedule a little bit, or open the floor for questions.
Thanks, Phil. That's much appreciated as well on the time.